Okay, in this video we're going to talk about our first of two reaction types. This type is called proton transfer, and we're going to talk about a key concept of proton transfer reactions, which are conjugate acid-base pairs. Right, so this is the first of two reaction types. In our next video, we'll talk about the second of two types, which is neutralization. So if you remember how in the previous video I said that every hydroxide will be a base, but there are also a lot of bases that aren't hydroxides. Proton transfer is the reaction type that we use, or the pattern that we use, when the base is not a hydroxide, so it doesn't have OH on the end. It's still going to work the same way as what we were working with on the last slide when we reacted things with water. The acid on each side of the reaction is going to donate its proton to the base on each side of the reaction, and the base will accept that proton. Right, so what this means to keep in mind is that there are now going to be one acid on each side of the equation, one base on each side of the equation. One of the things that we're going to do is we're going to draw curved arrows to represent the proton moving from the acid to the base. Right, that's the entire point of this reaction. And just as a little heads up, you should be able to identify what the conjugate pairs are in this proton transfer reaction. Right, so let's start talking a little bit about conjugate pairs. So a conjugate pair, very simply put, is an acid and a base that have very similar formulas. Their formulas are so similar that they happen to only be different by a single H+ ion. Right, so water can be an acid. Its conjugate base is hydroxide, because if you take away H+ from water, you're left with OH-. Similarly, if water was acting like a base, its conjugate acid would be H3O+, because H3O+ and H2O only differ by a single proton. Right, so what we have here is we have an example reaction. We have nitrous acid reacting with ammonia. Nitrous acid, because the formula starts with H in this case, is going to be our acid. It's going to donate the proton to NH3, right? So HNO2 was our acid, NH3 is our base. I'm going to draw a curved arrow from the hydrogen on the acid to the base, showing that the proton is moving, and I'm going to label this arrow as H+. Right, so that shows our movement of the proton. And then those will produce the nitrite ion, NO2-, and the ammonium ion, NH4+. Now what we have to do for this side is we have to do the reaction, but in reverse. Right, so in our reverse reaction, NO2- can't lose any protons. It's gaining in the reverse reaction, right? For the reverse reaction, it's going from NO2- to HNO2. Because it's gaining a proton, NO2- is our base. That means NH4+ has to lose the proton. That's going to be our acid. And same thing as I did on the other side, I'm going to draw a curved arrow from the hydrogen in my acid over to my base. I'm going to label it as H+ because it's a proton. Right, so this is our overall reaction in this case. Now, in order to find the conjugate pairs, I have to look for the similar substances. There are two pairs of similar substances here. We have HNO2 and NO2-. Right, of those two things, HNO2 is an acid, and NO2- is its conjugate base, because it differs by a proton. Then we have another pair, which is NH3 and NH4+. NH3 is the base in our original reaction, which means that NH4+ is the conjugate acid, because it has that extra proton. Right, so this is how you identify a conjugate pair. Just look for the two things that only differ by a single hydrogen. Right, so let's try an example of this out. Let's start off with the acetate ion, C2H3O2- plus HiO3. So if we look at this, Which one of these looks like it's going to react as an acid? Judging by the formulas, I would say the HiO3, again, the formula begins with H. That kind of signifies it as an acid. Right, so HiO3 is going to lose a proton, which means it's an acid. C2H3O2 minus is going to gain that proton, making it a base. So when C2H3O2 minus gains a proton, it becomes HC2H3O2. And then when HiO3 loses its proton, it becomes IO3 minus. Now on the other side of the reaction, the HC2H3O2 is going to act as our acid because that will lose the proton. And the IO3 minus will act as our base because it's going to gain the proton. Right? So then I just draw in the curved arrow and label it. And this is my proton transfer reaction. And to just identify the two conjugate pairs, I have C2H3O2 minus, which is a base, with HC2H3O2, which is an acid. That's one pair. And then the other pair is HiO3, acid, with IO3 minus, base. Right, so that's what I'm going to be asking you to do in class. And our next video will cover the second reaction type, which is neutralization.